Well, hey everybody, it's Tom here. Welcome back to my shop. So, you saw the jib crane build part 1 when I was trimming off the tops and the back corner on those gussets before I welded them onto the column to the base. I had them over here at the DoAll bandsaw, and making it easier to weld so you don't have little sharp corners or points. You're just going to burn them up anyways when you weld. So I was over here at the bandsaw cutting them off, and I noticed there was an issue, and I delve into it, and well, I found the problem. So going to be a fun little fix. Figured I'd film it, just show you kind of what goes on behind the scenes, keeping the machines up and running. So let me grab the camera and I'll get you in closer. So you're looking at my 1943 DoAll bandsaw. This is model ML16. So the wheels are 16-inch in diameter. I think the table is 24 by 24. So you got 12 inches here and a couple more. So I probably got about 15 inches of throat here to cut stuff with. So when I was cutting, and pushing the blade, you've got these blade guides. As you can see, I've already taken everything apart, but they're in here and they hold the blade, and as you push the blade, you have a bearing back here and the blade rides on the bearing. Well, this bearing seized up, so that was the issue. The blade was rubbing, and the bearing here, it's a ball bearing as you see, has this, for lack of better words, protective cap over it. So it goes on like this, and once it's seized up, you can see the blade just cut into it and destroyed it. The bearing is an odd size, but I got lucky and I found a new old stock on eBay. Check out this cool old box. I don't know how old it is, 50s, 60s maybe. I'm not sure when they stopped making them. This bearing is a C as in Charlie, 96P as in Paul. So there it is. But it comes just like that. We don't have this protective cap. Can't get it, so we're going to have to make one. That's what this fun project is going to be about. Doesn't seem to be hard. I thought it might be hard, but you run a file on it and it scratches it. So material of choice, I don't know, maybe a piece of 4140 or 1144. I guess would be just as durable. So challenge is going to be just making this little itty bitty part. I'm used to making big stuff. So let's go out to the part materials storage bin and see what we got, and then we'll get over there to the small lathe, chuck it up, and make this little cap, and we'll get this thing back together. Let me show you what the measurements are. Hopefully it's not getting washed out. So the OD of this thing is 0.820 or 20.83 millimeters, and the ID inside there, or basically the OD of the bearing, is 0.748 or 19 millimeters, and the width 0.262 or 6.65 millimeters, and the depth going to the back of the wall there, I guess we'd call it, is 0.226 or 5.72 millimeters, which gives us the difference of 0.036 or 0.91 millimeters, which is basically the thickness of this wall here. So found a piece of 4130, so that'll be nice and tough, 7/8 in diameter, so we don't have to take it down but just a smidge, don't have to waste a lot. So let's get turning. Well, sometimes you do get lucky. I was thinking, it'd be nice if I could just run an end mill in here, cut that out, bam, 19 millimeter. But I'm like, ooh, I don't have a lot of metric stuff. Let me check. Well, the machining gods actually like me, because believe it or not, I have a 19 millimeter or a .748. I know you guys can't read it because it's very faint. End mill, 4-fluter. Looks like it's been resharpened, so it may cut just a smidgen small, which would be, you know, perfect, because then we can just run a small boring bar in there and get it to its final dimension. But wow, I love it when I get lucky and be able to hold it. I got a ER32 collet holder with Morse taper number 3, so we can stick this in the back of the tailstock, and we can run her in, and bam, we'll be done. How nice is that? Got a 1/2-inch end mill in here. We'll just use that to chew it out, and then we'll run that 19mm in. Measure this end mill, it's .740, so that regrind took 4 thou off each side. We'll just have to kiss it with a boring bar. Figured I'd check the hole, and looks like Bozo showed up, because even with that end mill being small, watch, it goes right in. I mean, so it cut large. Let me get her out. So this is a 750 gauge pin, and it goes in. So yeah, all right, let me face all that off, and we'll start over. And I guess I won't use that 19mm since it cuts large. We'll just throw another end mill in, like a 1/2 inch or maybe even 9/16, and then we'll just have to bore from there. Alright, let's try this again. Let's slow her down. That's why. Look at her walk around cutting it large till it can find a spot. This is a center cutting. Of course, I think it is a reground too. Yeah, must not be a good regrind. Let me get another one. Hope it ain't gonna be one of them days. Wobbling all over the place. Get that hole cleaned up and we'll get a measurement. That is a 5/68 gauge pin. Just been whittling away off camera. That's a 7/30 gauge pin. So we've got 18 thou more to go. Turn the tip around so I got fresh point on that carbide. And we'll take another pass or so and hopefully we'll hit our numbers. So I'm going to dial in 5. Let's see if it takes 10. And then we'll know how much deflection we got for the last pass. Let me get a measure. Alright, dialing it in, that should be it. Alright, let me move you guys a little bit closer. I'll check it with a gauge pin before I stick it in there, because it'll get stuck. Alright, 7/48 gauge pin. There you go. Nice. So she goes in. Sweet. So if we try to get this bearing in, I imagine I wouldn't be able to get it back out. Just make sure she wants to start. Yeah. Alright, cool. Nice. Let me break that edge just a smidgen. We'll get the OD turned. And I made this a little bit deep, so then we'll figure out the depth, and then I can just face it down and we'll get the right depth on this thing. Alright, that's put us at the depth we need now. Let's turn the OD. Okay, that should be basically all the turning, except we got the parter off. But I don't want to do that yet, since we have to cut the grooves there to turn this edge into fingers. I guess that's what the original concept of that thing is. Set up over here at the mill, so we need to cut these slots here. Gotta see that. So this one's got 5, but I don't have a 5-sided collet block. Don't feel like setting up the rotary table or the dividing head, you know, just to cut this. So we're gonna go with 4. Think we'll be all right. So run the end mill in, hit the top one, come down, hit the bottom one, and then all we gotta do is rotate this 90 degrees and rinse and repeat, and that'll give us 4 slots. So basically give us 4 fingers instead of 5. But like I said, we should be all right. Find my 0 here. I'll go in 150. Right there. Should be it right there. We're gonna reach. Yep, there, barely. Of course, you guys can't see nothing, can you? Hang on, let me move you a little bit. Right there. Alright, cool. Alright, let me rotate the block 90 degrees. Alright, we got her. Take a while. I'll bring you back. I want to listen to that the whole time. Alright, we got her finally. And it's down in the chip pan. Hang on, let's move you over here. Let's see if we can find her. There it is. Alright. Got a nub to take off. That's alright. Looks like we got one bearing cap. Yay! Alright. Well, here it is. Here's the little fiddly part we made to replace this one here. Like I said, I went with 4 fingers instead of 5 just because it was easier. I don't think it's going to affect anything. I got a good fit here. So, new bearing will go in here. I'm going to go over there and put it on the arbor press and just send it home. And I'll get the bandsaw back together, and you guys will meet me back when everything's together and running. Everything's together, seems to be working. Got you in as close as I can. So there's the bearing with the cap on it. And like I said, when you push your work into the blade, it runs against the blade and rotates. And it looks like I need a new blade. There's a couple bad teeth right there. Huh. Looks like we got a win. What you doing, buddy? You waiting for me to play? Is that the problem? Is that the problem? Ooh, I got it. Ha ha ha. You ready? Airmail. Say hi to everybody on YouTube. Just hanging out with my dad in the shop today. He's making some fiddly part and he ain't playing with me. Right? Alright, you gotta drop it. Of course, you're gonna drop it way down yonder. Oh, you killing me, buddy. Well, there you go, guys. One little bearing cap made. Works as it should. So I got the DoAll back up and running. So it's nice to be able to make obsolete parts. Appreciate you guys watching and hanging out with me. Welcome all my new subscribers. I know this wasn't mind-blowing, just a small little project, but you know, hey, sometimes you gotta fix your stuff, right? So waiting on some material so I can get back on the jib crane build. Don't know if I'll have that done and ready for you guys next week or two. We'll see how it goes. But if I don't, then you know it just didn't happen. Maybe I have something coming in the door or some paid work and I can film that. We'll see. But with that, it's going to be a wrap. Appreciate you watching. Appreciate you subscribing. Leave comments down below. I love talking with you guys. Thumbs up help the algorithm move my little channel up. And we'll catch you on the next project and next video. All right? See ya. Bye.